Hello students, in the last class we have solved some examples on the angle between two lines, and while solving those examples we have also used condition for the perpendicularity and parallelism of two lines. And now in the today's class we are going to study the next article, which is the change of origin and change of direction of axis. Last three articles of our first unit syllabus are covered from the chapter number 5th, which is the transformation of coordinates. Coordinates can be transformed in two ways. The first way is the change of origin and the second way is change of direction of axis. So let us begin with the first one article, which is the change of origin. So the question is to change the origin of coordinates without changing the direction of axis. Means we have to only change the origin and we are keeping the direction of axis as it is. Okay, we are only going to change the origin, position of origin we are going to change, and then what happens to the equation of the geometrical entity, that we are going to discuss here. So now consider the diagram first of all here. Suppose that originally the frame of reference is the x-axis is OX, y-axis is OY and z-axis is OZ, and intersection of these three axes is the origin O. And the new frame of reference is denoted by O dash x dash, O dash y dash and O dash z dash. Intersection of these three mutually perpendicular lines is O dash. And you have been observed that this new origin is different from the earlier origin. In the new frame of reference, the three mutually perpendicular axes are parallel to the original x-axis, y-axis, z-axis. Okay, so the question is to change the origin of coordinates without changing the directions of axis. Let OX, OY, OZ be the original axis and O dash x dash, O dash y dash, O dash z dash, the new axis respectively parallel to the original axis. Let the coordinates of O dash referred to the original axis be F, G, H. Suppose coordinates of O dash with the original means our regular frame of reference, which is about the x-axis, y-axis, z-axis. Okay, suppose that the coordinates of O dash are F, G, H. Coordinates of O dash are F, G, H. Next one, let the coordinates of the point P be x, y, z. Coordinates of point P are suppose x, y, z with reference to the original frame of reference, and coordinates of P be the x dash, y dash, z dash with reference to the new frame of reference. Okay, then we have to obtain a relationship between x, x dash, y, y dash, z, z dash. Then for that purpose, we will draw a perpendicular from point P on the yz plane, also on the y dash, z dash plane. We draw PL perpendicular to the parallel planes YOZ and Y dash OZ dash. Obviously, as the axes are parallel, therefore coordinate planes are also definitely parallel to each other. You may observe that the plane YOZ is parallel to the Y dash O dash Z dash plane, and we have drawn a perpendicular from point P on the YOZ plane as well as on the Y dash O dash Z dash plane in such a way that it intersects the YOZ plane at point L and it intersects the Y dash O dash Z dash plane at point L dash. So draw PL perpendicular to the parallel planes YOZ and Y dash O dash Z dash, meeting them at L and L dash. This is the perpendicular from point P on the YOZ plane, it is PL, and perpendicular from point P on the Y dash O dash Z dash is PL dash. Obviously then this distance LP will be equal to x, and the distance L dash P will be equal to x dash. As we have considered that coordinates of point P with reference to the original axis are x, y, z, therefore distance PL is equal to x, and the coordinates of point P with reference to the new frame of reference is x dash, y dash, z dash, therefore PL dash will be equal to x dash. Okay, so therefore LP equal to x and L dash P is equal to x dash. Now next one, we observe that the distance L dash is equal to the length of the perpendicular from O dash to the YOZ plane. From this point O dash, if we draw a perpendicular on the YOZ plane, then that length will be equal to the length L dash. Okay, and as the x coordinate of this point O dash is F, therefore this distance L dash will be equal to F. Okay, next one, we have the distance LP is equal to the distance L dash plus L dash P. So therefore this x which was the x coordinate of point P with reference to the original frame of reference. So it is equal to x dash means x coordinate of point P with the new frame of reference plus F means the x coordinate of point O dash. So therefore we have obtained x equal to x dash plus F. And similarly, if we draw the perpendiculars from the point P on the XOY plane and on the XOZ plane, then we will get y equal to y dash plus g and z equal to z dash plus h. So therefore, if the origin is shifted from 0, 0, 0 to the point FGH, then the coordinates of point P will become x dash plus f, y dash plus g and z dash plus h with reference to the new frame of reference. Hence, if in the equation of any surface, if we change x, y, z by x plus f, y plus g, z plus h respectively, then we will get the equation of the same surface referred to the point FGH as origin. So this is to be remembered here. So if the origin is shifted to the point FGH, then in the equation of any surface, we have to put x plus f for x, y plus g for y and z plus h for z to get the equation of the same surface with reference to the new origin. We will consider one example based on this. Find the equation of plane 2x plus 3y plus 4z equal to 7 referred to the point 2, minus 3, 4 as origin. Directions of axis remaining the same. Here the equation of a plane is given with reference to the original frame of reference, that is our original XYZ axis, and if the origin is shifted to the point 2, minus 3, 4, then the equation of the same plane is asked with reference to the new origin. So we will solve this one. Method just we have seen in the theory, now we will solve this one. Origin is shifted to. Origin is shifted to the point. Origin is shifted to the point FGH, to the point FGH, and which is here given as 2, minus 3, 4, means f is equal to 2, g is equal to minus 3 and h is equal to 4. Okay, so then the equation of the plane also changes. So therefore to obtain equation of given plane, with reference to the new origin, we have to replace x by x plus f. X plus f means that is x plus 2. Similarly, we have to replace y by y plus g, and y plus g means y minus 3 as the value of g is minus 3 and z by z plus h, and z plus h means z plus 4. Okay, so this will changes. So therefore we will get the equation of plane. Therefore equation of given plane becomes, equation of the plane was given as 2x plus 3y plus 4z equal to 7. Okay, so equation of the plane becomes, so 2 into, for x we have to put x plus 2, 2 into x plus 2, then plus, next term was the 3y, so 3 into, for y we have to put y minus 3, then plus, next term was 4z, 4 into z, for z we are going to substitute z plus 4, and this is equal to right hand side 7 as it is. So we'll simplify this one. So that is 2x plus 4 plus 3y minus 9 plus 4z plus 16 equal to 7. That is, this can be simplified further. So after simplification this gives 2x plus 3y plus 4z, then this 4 plus 16 is 20, 20 minus 9 is the 11, this 11 when transferred to the right hand side it becomes minus 11, so 7 minus 11 means minus 4. Okay, so it is minus 4 to the right hand side, and so this is equal to minus 4, and this minus 4 can be transferred to the left hand side, and therefore we will get 2x plus 3y plus 4z plus 4 equal to 0. So this is the equation of the given plane with refer to the new origin that was shifted to the 2, minus 3, 4. So like such the example can be solved. So after solving one example based on the change of origin, next article is the change of direction of axis. So we'll go for it. Now next article is change of the direction of axis. Means if we keep the origin as it is, if we don't change the position of origin, and if the direction of axis are changed, then what changes becomes in the equation of a surface that we are going to study in this article. So the question is to change the direction of axis without changing the origin. Here we are keeping the origin unaltered, means as it is, and just we are going to changing the direction of axis. So the solution is, let L1 M1 N1, L2 M2 N2 and L3 M3 N3 be the respective direction cosines of the new axis OX dash, OY dash, OZ dash referred to the original axis OX, OY, OZ. This means that the original axes are OX, OY and OZ, and we are changing the direction of axis, means the new axis of reference are OX dash, OY dash and OZ dash. Obviously these new axes are also mutually perpendicular to one another, means OX dash is perpendicular to the OY dash as well as OZ dash and so on. Okay, and we are supposing that the direction cosines of OX dash are L1 M1 N1, direction cosines of OY dash are L2 M2 N2 and direction cosines of OZ dash are L3 M3 N3. Next, let x, y, z and x dash, y dash, z dash be the coordinates of any point P referred to the two system of axes. Suppose that P is any one point. Okay, let us suppose that P is here. Suppose P is any one point. Then the coordinates of P with reference to the original axis are suppose x, y, z, and coordinates of P with reference to the new axis are suppose x dash, y dash, z dash. Next, then from the point P, we will draw the perpendicular Pn on the plane x dash o y dash, on the plane x dash o y dash, on this plane, okay, meeting it in L dash, so that the distance, that one is O, that distance will be the PL dash. So, meeting it in L dash, then OL dash will be equal to x dash and L dash n dash will be equal to y dash, okay. OL dash equal to x dash and L dash n dash will be equal to y dash, as well as n dash p will be equal to z dash. So next, then the projection of OP is equal to the sum of the projection of OL dash, OL dash n dash and n dash p on the OX dash, and therefore we have x will be equal to L1 x dash plus L2 y dash plus L3 z dash. Similarly, we will get y equal to m1 x dash plus m2 y dash plus m3 z dash and z equal to n1 x dash plus n2 y dash plus n3 z dash. This system of equations we are denoting by the A. Next, similarly, if we proceed, then we will get x dash equal to L1x plus m1y plus n1z, y dash equal to L2x plus m2y plus n2z, and z dash equal to L3x plus m3y plus n3z. Let us denote this system of equations by the equation number B. Next, then the results A and B, these both the system of equations can be written systematically in form of a table. Okay, it can be written systematically in the form of a table x, y, z, x dash, y dash, z dash, and like such those equations can be written as, okay, means x dash is equal to L1 into x plus m1 into y plus n1 into z, y dash is equal to L2 into x plus m2 into y plus n2 into z, and z dash equal to L3 into x plus m3 into y plus n3 into z. Similarly, x equal to L1 into x dash plus L2 into y dash plus L3 into z dash, y equal to m1 into x dash plus m2 into y dash plus m3 into z dash, and finally z equal to n1 into x dash plus n2 into y dash plus n3 into z dash. Okay, so like such is the result about the change of the direction of axis. So in the today's class we have studied two articles. In the first article we have studied the change of origin and we have also solved example on it, and in the second article we have studied the change of direction of axis. So we'll stop here and we'll continue in the next class. Thank you.